let's look at work and calculus. So work is equal to the force times the distance, or FD. The force is equal to mass times acceleration, or the weight of the object. Now work is either measured in foot-pounds, which we denote like this, or joules, which is a Newton meter. So let's go ahead and use this on an example. So a vertical right circular cylindrical tank measures 18 feet high and is 20 feet in diameter. It is full of oil weighing 23 pounds per foot cubed. Find the amount of work required to pump the oil to the level of the top of the tank. Okay, so let's label our diagram. So that is 18 feet high. The diameter is 20, so the radius will be 10. Okay, so what we want to do is we want to find the amount of work it takes to move each little slice of oil up to the top of the tank. So the weight won't be constant as we're going along through this, because as we pump more water out of the tank to the top level, there'll be less weight of the oil inside the tank. So we're going to find the work for each individual slice, or at least for one slice, and then take the integral, or the sum of all of the slices together. So if we look at this slice, let's kind of bring it out here. Sorry, that's not a very good picture, but you get the gist. So the width of that slice, or the height of it, is, we'll call it dy. That is the height of the slice. Okay, so to find work, we need to find the force, or the weight. So the force will equal our weight. And we know that the oil weighs 23 pounds per foot cubed. So to find the total weight of the tank, we're going to do 23 times the volume of the tank. So the volume of a cylinder is pi r squared h. So in this case, our radius is 10, and our height is dy. So that is going to equal, let's see, 10 squared is 100 times 23, so 2300 pi times dy. So that is our force. Now we also need to know the distance, because again, work is equal to force times distance. So the distance that each slice is moving depends on the position of the oil. So this slice of oil doesn't have as far to rise as this bottom slice of oil. So the slice is variable. So we're going to call that distance that it moves y. So distance y. So the work of a single slice, or the work to move a single slice, work for one slice, is going to equal the force times the distance, so 2300 pi dy times the distance, which is y. And again, to find the work done for all of the slices, or for the whole tank, we're going to take the integral. So we're taking the integral. The height is 18, so we're going from 0 to 18. And we're doing that up 2300 pi y dy. Okay, so you could pull out the 2300 pi, since it's a constant, and then just integrate y dy from 0 to 18 pi. And you would get 162. And then you multiply that by 2300 pi. And your final answer is 372,600 pi foot-pounds of work. So foot-pounds.